In 1969, humanity crossed the impossible. For the first time, a human being walked on another world, and the lunar dust preserved the footprints of that achievement. 3 years later, when Apollo 17 lifted off from the moon's gray surface, no one imagined that it would be the last time for more than half a century that human feet would touch a world beyond Earth. What should have been the beginning of a new era became a silence that still echoes today. Why have we never gone back? Decades have passed. We now live in the age of artificial intelligence, reusable rockets, self-driving cars, and machines capable of simulating human thought. SpaceX lands its massive boosters as softly as feathers falling from the sky. And yet, half a century later, no one has managed to repeat the feat of 1969. It seems absurd, but the answer is more complex and more human than one might imagine. To understand the present, we must return to the moment when it all began. It was the morning of July 16, 1969, at Cape Canaveral, when the roar of the Saturn V tore through the air with the force of thunder. The largest rocket ever built by humankind rose from the ground, bound for history. Inside it, 3 men, Armstrong, Aldrin, and Collins, embarked on a journey that would forever change our relationship with the cosmos. The world watched in awe, unaware that in that very moment we were witnessing not just a technological breakthrough, but the limits of a civilization willing to risk everything to prove what it was capable of. And it was precisely in that moment of glory and thunder that the future began to fall silent. Five decades separate the deafening roar of the Saturn V from the calculated silence of the Artemis engines. 2 moments in human history divided by time, yet bound by the same impulse to return to the moon. In 1969, the goal was clear: win the space race and show the world who commanded the future. Apollo 11 was more than a scientific mission. It was a political symbol, a triumph over the Soviet Union. NASA held nearly 5% of the entire US federal budget, and space exploration was treated as a matter of national pride. The objective wasn't to understand the universe, it was to conquer it. Every rocket launched was a shout of power. Every step on the lunar surface, a declaration of ideology. Today, the race is different. The enemy is no longer another nation. It's time, distance, and cost. Humanity doesn't just want to touch the moon again. It wants to remain there, to build bases, test technologies, and pave the way to Mars. The Artemis mission embodies this new era, more cautious, more complex, and paradoxically slower, not for lack of technology, but because of an excess of responsibility. Every component is tested, every maneuver simulated, every risk meticulously calculated. Audacity has given way to precision. But the difference between the eras goes far beyond technology. It lies in the very soul of humanity itself. In 1969, the world breathed risk. The space race was driven by courage and rivalry. Every explosion was a lesson, every failure a step forward. When the Apollo 1 module was consumed by flames and 3 astronauts died during a simple pressurization test, the program didn't stop. Mourning lasted days, but determination lasted decades. Society accepted danger as the price of achieving the impossible. Today, the scenario is different. We live in an age of protocols, reports, and accountability. The death of a single astronaut would become a global crisis, a political headline, a national trauma. NASA learned that, in the era of instant communication, a mistake costs more than a technical failure. It costs reputation, credibility, and funding. That's why the pace of exploration has changed. Everything is tested, reviewed, and certified to exhaustion. The SLS rocket and the Orion capsule are not just machines. They are monuments to modern bureaucracy. Every valve, every screw, every line of code must be validated by dozens of teams. The result is a safer program, but also one that is slower, more expensive, and emotionally distant from the daring spirit of the 1960s. Apollo was born from brilliant improvisation. Artemis is born from necessary caution. Between urgency and control, we lost our haste, but perhaps we gained awareness. Today, humanity still looks to the sky, only now it does so with a fear of falling. And even so, it keeps trying to rise. When Apollo 17 lifted off from the lunar surface in 1972, the roar of its engine echoed as the closing note of an era. In that moment, humanity was leaving not only the moon, but also the peak of its own audacity. The Apollo program was shut down not for lack of technology, but because it had fulfilled its political purpose. The conquest of the moon was a race, not a destination. It existed to prove power, not to build a future. With the end of the Cold War, the massive investment that fueled skyscraper-sized rockets lost its meaning. NASA's budget, which once reached nearly 5% of all U.S. government spending, plummeted to less than 1%. The production lines of the legendary Saturn V were dismantled, and the knowledge accumulated over the years scattered across archived reports and the minds of engineers who would soon retire. The moon ceased to be a frontier and became a memory. As Earth plunged into the digital revolution, space turned into a distant realm, kept alive only by robots and automated probes. Humanity, which once touched another world, spent the next 50 years confined to Earth's orbit. Gazing from afar at what it had already conquered, it was as if, after overcoming its greatest challenge, the human species had lost its reason to keep trying. And that silence, that half-century gap between human footsteps on lunar dust, was not merely a technological pause, it was a pause of purpose. 50 years later, humanity once again sets its sights on the moon. But this time, the purpose is entirely different. Artemis doesn't seek to repeat the glory of a single leap. It aims to stay. What was once a symbol of conquest now transforms into infrastructure. The new space architecture reflects this shift in philosophy. The SLS rocket launches the Orion capsule and its crew toward lunar orbit, while a prescient Starship waits at a calculated rendezvous point. a near rectilinear halo orbit around the Moon. To reach that position, the Starship was refueled in orbit by a fleet of autonomous tankers, performing a precise orbital choreography that pushes the boundaries of engineering coordination. Docking takes place thousands of kilometers from Earth. Two astronauts cross the metallic hatch, transfer to the lunar lander, and begin their descent. On the surface, they walk, install instruments, collect samples, and test technologies Apollo could never have imagined. Suits designed to endure for weeks, sustainable power systems, inflatable habitats, and the extraction of lunar ice for fuel. Every stage of the mission was designed not merely to arrive, but to remain. What appears complex, refueling, docking, multiple launches, is in truth the only way to build permanence. It marks the birth of lunar logistics, the first rehearsal for an economy that spans worlds. The Moon ceases to be a destination and becomes a platform, a testing ground for Mars, a base for mining, a laboratory for the future. The dream is no longer simply to reach it. The challenge now is to stay and to turn its gray dust into the foundation of an interplanetary civilization. If Apollo raced against an adversary, Artemis races against statistics. The enemy now is not geopolitical. It's the margin of error. Challenger and Columbia taught that every failure is more than an accident. It's a national wound. Since then, NASA has come to treat risk not as part of the journey, but as a variable to be reduced to its lowest possible level. That shift comes with a cost: time. The Orion capsule completed Artemis I with flawless technical success, but small cracks in the heat shield, a honeycomb-structured ablative material designed to burn away in a controlled manner, triggered alarms. The result was a chain of meticulous inspections, plasma tunnel tests, manufacturing reviews, thermal simulations, new qualification flights. The schedule slows, not from incompetence, but from maturity. Modern engineering has become more precise and, paradoxically, slower. Today, every screw, every line of code, every cryogenic valve must pass through audits, certifications, and environmental reviews. Supply chains are global, systems are interdependent, and space has become more political than ever. The same phenomenon affects all human infrastructure. Subways, reactors, airplanes, everything takes longer. Artemis is no exception. Validating high-orbit dockings, certifying orbital refueling, approving propulsive landings, and ensuring safe returns require a network of precision Apollo's era never knew. The rhythm is different because the purpose has changed. It's no longer about proving superiority, but about building reliability, turning space from a stage of stunts into a field of sustained operation. The true legacy of Artemis may not be the return to the Moon, but the knowledge that will make it possible to stay there, and then go beyond. The core difference between Apollo and Artemis lies in an invisible fuel: recurring funding. Apollo burned the equivalent of nearly $290 billion in today's money during a historic sprint. Artemis must endure with roughly a third of that, while NASA simultaneously funds telescopes, probes, climate research, and aeronautics. The answer has been to open the door to private industry, Service-based contracts, performance targets, competition among providers, shared risk. SpaceX brings the promise of scalability and cost reduction through reusability. Other companies are developing landers, communication systems, power infrastructure, and payload delivery. This isn't cosmetic, it's structural change. If usable ice truly exists in the moon's polar craters, it can become water, oxygen, and hydrogen, life support, breathable air, and local fuel, with logistical satellites in stable orbits, a small station in NRHO, regular landings, and asset maintenance. The cislunar ecosystem begins to make economic sense. The more actors involved, the more resilient the network becomes. The more supply routes established, the cheaper permanence gets. That's how aviation and the internet matured, through standardization, competition, and scale. For the first time, the moon stops being a project and starts behaving like infrastructure. In the end, we're not returning to the moon to recreate a photograph. We're returning to change the story. Apollo proved reach. Artemis must prove permanence. Staying means learning to extract local resources, operate in eternal cold, generate power through long nights, build radiation protection, standardize landings and dockings, and master refueling and interplanetary logistics. Each process perfected on the moon shortens the distance to Mars. And the symbolism is unavoidable. One generation grew up hearing that we went to the moon. Another will grow up seeing that we live nearby. Science gains continuous access to rocks untouched for billions of years. Engineering matures technologies that flow back to Earth as new materials, energy systems, and automation. Above all, humanity trains its most essential muscle, the ability to build far from home. When a new footprint joins the old ones, it won't be repetition. It will be the first step in a continuous line. The true frontier has always been internal, to turn will into method and method into permanence. The moon is only the first chapter of a long story. This time, the page won't close when the rocket fades beyond the horizon. It will keep being written, night after night, on the gray dust we've chosen to call our neighborhood. If you enjoyed the video, don't forget to subscribe, leave a like, and share your thoughts in the comments below.